Hey everyone, welcome to your Play Pause It for the week. We are going to be covering systems. We are going to be in systems for a few more lessons, and we're going to talk about the second way to solve systems using substitution. So go ahead and grab your notes and we'll get started. A friendly reminder, I'm going to put the link in the Play Pause It. Don't forget to sign up for Be the Teacher. You can get extra credit. Don't worry if you feel nervous. This is a great opportunity to meet with me beforehand. We'll pick the topic that you're comfortable with. We'll go over the question, make sure you feel ready to go, and then you can present it to the class. And if you're feeling a little out of your comfort zone, this is just kind of a really good time to do it because I'll be there to support you, and so will your classmates. This week in our live classes, we have our quarter 2 CIP benchmark. So this is a little different from quarter 1. If you recall, we met at a separate time, 2 p.m. on a Tuesday or Wednesday, and we got some feedback both from learning coaches, students, and teachers that it would be better held during a regular class connect. So I already see you this week, either Wednesday or Thursday. So does your ELA teacher. And so we're just going to do it during our class time together. So that's either going to be Wednesday or Thursday. Don't worry. Remember, this assessment is just for learning purposes for myself, your learning coach, you. We reviewed it, parts of it last time. Remember, we picked the most commonly missed questions. And so it's just a really great kind of pulse check to see where we're at. You'll get to use your Desmos graphing calculator, and I'll be in the room if you have any questions that I can support you with. All right, so last live class, we talked about solving systems graphically, excuse me, and we know that the solution to a systems graph is where those lines cross. That coordinate point right there is the solution to the system. And it's the solution because it works in both graphs. And here, where they cross, there can be more than one solution to a system. And if you're looking at those tables of graphs, we know, tables of points, we know the solutions are where the points are the same, right? So this f of x graph, this point here is negative 2, 4. This point is also negative 2, 4. This is the x value, and this is the y value for the corresponding graphs. So here is one solution, and here's the second. So anywhere that those y values are the same is where you're going to have a solution, just like we saw here. And of course, the x value is the same, right? Because it's the same. Negative 1, 2. So this one has two solutions. So now we're going to just do one quick review question. We're going to practice graphing these in our Desmos calculator because we want to practice as much as possible and get used to how it works, right? So we're going to take each of these and put them into the Virginia, the green bar, Desmos, and you can just come right up here and type it as you see it. You can either use your keyboard or you can come down here and click the calculator's keyboard. And I'll do the negative 3 divided by 2 for the fraction. Make sure you arrow over to put the x. If you didn't arrow over, see the x would have been stuck in the denominator. So you want to make sure to put the x where it needs to be. All right, and the second graph here is 1/2 arrow over to the x power. So you can use this key down here to do a variable b, meaning anything you want. It just puts it up top for you, and I'll type in x, and then -1. Just make sure you arrow over. If I did not arrow over, look what happens. Hold on. Oh, it's like remembering. Well, that's smart. Thanks, Desmos. I didn't think it was that smart. That time it actually recalls and arrows over for you. All right, so you can see here we have two solutions, and you can see them on the graph right there. -2, 3, and 0, 0. This means If you put this x value, -2, you'll get a 3 out in either one of these functions. If you put in a 0, you'll get a 0 out. And you can try it. Look, if I put 0, see, you get 0. If I put -2, oops, hold on. If I put -2 for x up here, you get the 3. So it does work. All right, let's get back to our play. Pause it. So now, method number 2, substitution. Now, the remaining 3 methods are all algebraic. So we're going to do them, I guess you could say, by hand. So before we get into the method, just let's review how to solve for a variable. If you remember, this is called like literal functions. They're literal because we're not solving for an actual number. We're just sort of rearranging the equation. We're going to get x by itself. So to do that, we need to move the y. So it's a plus y. We'll just subtract y from both sides. And here you're left with x equals 2 minus y. And that's it. This is what we do with literal equations. We just rearrange the way the function looks. Here's our second one. Solve for t. There's our t. This is a positive 3, so we'll do the opposite and subtract 3. We're left with a negative t equals w minus 3. Almost finished. We got to get rid of this negative. You could multiply or divide by a negative. Really, there's a 1 here, right? So we divide everything by -1. And you get negative w plus 3. And that's it. We're done with that. We got t all by itself. This is going to come in handy for us when we're solving our systems by substitution. So let's try one. Over here, I have some steps. You do not have to follow these steps, but I thought it might be helpful as you're getting used to this practice. Step 1 says solve one of the equations for a variable. Either equation, it doesn't matter. We just want to get one of the variables by itself. You could get y by itself. You could get x by itself. Honestly, whatever looks the easiest to you. So in this equation, this system, look, we already have one of the equations with a variable by itself. So let's use that one. Step 1 is done for us. Step 2 says plug that into the other equation. So we're going to substitute y as -5 into the second equation. And we're allowed to do that because this is a system. We're saying y equals -5. Okay, so everywhere you see a y, let's put -5. So instead of y, we'll put -5. All right, step 2 is done. Step 3 says solve for the variable. So now look, here's our equation. We only have one variable. Let's solve for x. So we can simplify. 4 times -5 is -20. We want to get x by itself, so we'll move the 20 over. And you get 5x equals 0. Next, we'll divide by 5, right? 0 divided by 5 is 0. So we got x equals 0. Remember, for a solution to a system, we are looking for some x, y coordinate point. We already have x and we have y. Step 3 is done. Step 4 says plug that solution into either equation to get the other variable. So if we needed to find y, we could plug x in and find y. But look, we already know y. Y is -5, so I'll put that here. And x is 0. But look what happens if we were to plug this x into that second equation. What do you think we're going to get for y? Let's see. This is 0. 4y equals -20. Divide by 4, and look. Y equals -5. Sure enough, it does. That's what they told us at the beginning, and that's what we found. And the reason why you get that for the second equation is because it's a system, right? And we know the solution will be the same in both equations. Now, here is one of the really cool things about systems is you can double check your work. Guess what? By using the Desmos calculator. So come over here and we'll just put in the two equations as they were given. Y equals -5 and y equals 5x. Nope, not y equals. 5x plus 4y equals -20. And I've put them on the same bar. Hold on. There it is. 0, -5. That's the solution that we found, right? So you can always double check your work. Let's try another one. Step 1, solve one of the equations for a variable. So look, we have equation number 1 and equation number 2. It's totally up to you. Whichever your brain feels like is going to be the easier one to get either x or y by itself. And you can do either equation and either variable. I'm liking equation number 2. It looks easier to me because there are no coefficients in front of the variables. So it'll be less math, right? So let's just solve for x. We'll add y to both sides. X equals y plus 13. All right, step 1 is done. We got x by itself. Step 2, plug that into the other equation. So we're going to, instead of x, we're going to put y plus 3 into the other equation. So that's going to be 4 times y plus 3, 13. Why did I say 3? 13 plus 2y equals 10. So instead of x, we're just going to write y plus 13. That's the whole substitution part. We're substituting y plus 13 for x. Now, if you look at this equation, we can solve for the variable. We can solve for y. So we're going to distribute the 4y plus, 4 times 13. Why not just very quickly check? 4 times 13, that's 52. Plus 2y equals 10. Okay, now we're going to combine like terms. 4y plus 2y is 6y. And subtract 52 from both sides. 6y equals -42. Getting closer. Now we'll divide both sides by 6. Come over here. 42 divided by 6, that is 7. That equals -7. Don't forget the negative. So we found y. Remember, we're going to have an x and a y. Y is -7. Step 3 is done. Last step. Plug that solution, this one, into either equation to get the other variable. So we found y, right? All we need to do now is find x. So let me grab another color. This is where you get to choose. You can plug this into any equation. You can plug it into number 1. Number 2, you can plug it in here. We're trying to solve for x, so I think we should plug it in here because this is already solved for x. So instead of y, I'm going to put -7. But you can put it anywhere and you'll get the same answer. And then you should get 6. X is 6. Let's go to Desmos, double check, and make sure that we get 6, -7. Because if not, maybe we made a small, sign mistake somewhere. So let's look. Okay, our first equation was 4x plus 2y equals 10. And the second one was x minus y. You should be trying this with me. Pausing, play pause it if you need to or want to. 6, -7. That's it. And you can celebrate, have a party. Woo! Let's see, can I give him a party hat? Yes. That's not too terrible. right? Ta-da! Feel like you need some teeth. Okay, moving on. Next example. All the steps are the same for everyone. It just kind of depends what system you're given, whether you might have to do a little bit more math or not. Let's solve one of the equations for a variable. Now, both of these look pretty hefty. They have coefficients in front. I'm leaning towards number 2 just because, I don't know, there's a 0. Zeros are usually helpful. So let's solve equation number 2 for, it doesn't matter, x or y. How about y this time? So we'll move the x term to the other side, and you get 6y equals negative 6x, and we'll divide by 6. That's not too bad. Y equals negative x. Okay, step 1 is done. We solved one of the equations for one of the variables. Okay, now we're going to plug that into the other equation. You can't plug this right back into the same one. That's not going to work because you'll just get the solution. You'll get 0. So we're going to plug this into the other equation for y. We're substituting it into the other equation. All right, so instead of y, we're going to write negative x. Step 2 is done. Step 3, let's solve. So we have x's here. We're going to solve for x. This is negative 2x. Combine like terms. So we get negative 9x equals 18, negative 18. And divide both sides by 9, negative 9. X equals 2. Yay! We found x. Now we're just looking for y. We solved for x. Now we're going to plug this solution, the x, into any equation anywhere, wherever you want. X is a number, so you can pick any of these. Well, let's plug it right here. So y equals negative 2. Done. And you can probably guess what I'm about to say. But we should go double check our work in Desmos. Let's do it. Trickiest part is making sure you don't type it in wrong, because that'll give you a different answer, right? Negative 7x plus 2y equals 18, and 6x plus 6y equals 0. Switch up here, negative 2, 2. Is that what we got? Oh, 2, negative 2? Did I mess up my signs? Oh, look. Hold on. See, this is good. This is a great example. So negative 7x plus 2y equals 18. 6x plus 6y equals 0. So it should be negative 2, 2. So let's look and see where I went wrong. Maybe I just wrote it wrong. Let's double check our work. Okay, so we're solving for y. Negative 6x, divide by 6. Okay, that looks good. Over here, so if y is negative x, we plugged in negative x for y. We got this. Negative times a positive is a negative. Oh, here it is. Ding, ding, ding. There's my issue. For some reason, I added in a negative 18. It's a positive 18. So we'll make that a positive, which makes this a negative. X is negative, so when you plug it in, you get a positive for y. I am so glad that happened because you can see how easy it is to make a tiny mistake. And so going to your Desmos calculator is perfect. It helps us confirm our work. Last one. Let's pick an equation. How about number 1? Look, x does not have a coefficient. So I'm going to solve this one for x. We'll subtract 7y from both sides. X is negative 7y. Step 1 is done. Now we're going to do what the name is called, right? We're going to substitute x into the other equation. And we'll get 2 times negative 7y minus 8y equals 22. 2 times negative 7 is negative 14. We can combine like terms. That's negative 22y equals 22. Last step, we'll divide both sides by negative 22. You get negative 1 for y. Okay, there's our y value. Now, well, look, step 2 is done, step 3 is done. Step 4, plug that anywhere, literally anywhere. But I think the easiest place to plug it is right here because you already have x solved for. So x equals negative 7 times negative 1. Instead of y, we put negative 1. X is 7. All right, let's go check it on Desmos, our good friend. Seriously, super good friend. Okay, x plus 7y equals 0. And 2x minus 5y equals 22. Is that right? No. Did I copy it down wrong? 2x minus 8y. I put 5. You got to type it in right. 7, negative 1. Woohoo! We got it right. Party time. All right, I hope that these steps didn't overwhelm you. Like I said, you don't have to like write all these steps out. You don't necessarily have to do it that way, but it works every time. Choose the best equation that your brain sees is the easiest to solve for one of the variables. Get that by itself. Substitute it into the other one, and that'll give you one of your answers. Then, once you have one of your answers, you can put it anywhere to find the other answer. Okay, don't forget, I will see you in live class this week. Class is always required, but you definitely don't want to miss it this week if you can, because we are taking our benchmark together in live class. Bye, everyone.